Hey guys, welcome to class. Today we're going to do lesson 4.6 where we're going to take a look at negative and zero exponents. Now before we jump into our lesson and taking notes today, I want to try to look for some patterns together. So go ahead and put your pencils or stylus down and take a look up at the board because you don't need to write this for just a moment. All right, let's start by looking at some patterns of things we know about positive exponents. So, if I ask you 2 to the 4th power, we've talked about how that would be 2 times 2 times 2 times 2. So that's 16. And then if we had 2 to the 3rd power, that would be 8. 2 to the 2nd power, we know is 4. 2 to the 1st power is 2. All right, so let's look at the pattern that we see here. What's happening as we move from 16 to 8, or 8 to 4, or 4 to 2? Hopefully what you notice is that each time we are dividing by 2. All right, so if that pattern continues, and we could have gone up and done like 2 to the 5th, 2 to the 6th, and we would see the same pattern. Well, if that pattern holds, then what would be 2 to the 0 power? Well, it would be 2 divided by 2, which we know is 1. All right, which leads us to the first rule that we're going to talk about that today, and that is that anything to the 0 power is always 1. And again, you can see that in our pattern here. Now, let's start looking at negative exponents. So for example, 2 to the negative 1 or 2 to the negative 2 and see what happens here. Well, we're going to follow the same pattern. So what is 1 divided by 2? It is 1/2, or the other way you could think about that is 1 over 2 to the 1st power. Now if we continue this pattern and again divide by 2, if we do, and I can show you over here, 1/2 divided by 2, or you could think about that as 2 over 1. We know with our fraction rules that we can change this to being multiplication by multiplying by the reciprocal, and that gives me 1/4. So this would be 1/4, or the other way you could think about that is 1 over 2 to the 2nd power. Let's take the next one, 2 to the negative 3rd power. As we continue this pattern, would end up being 1 over 8, or 1 over 2 to the 3rd power. I'll show you one more, 2 to the negative 4th power is 1 over 16, or again, 1 over 2 to the 4th power. So what happens when we have negative exponents is we bring the base and the exponent down to the denominator, and hopefully you can see that in our pattern here. Let me show you the same pattern even quicker with a different base. So let's say last time we used a base of 2, let's look at a base of 3. So if we have 3 to the 3rd power, that would be 27. 3 to the 2nd power would be 9. 3 to the 1st power would be 3. And the pattern that we see here is that each time we are now dividing by 3, because my base is 3. So if this pattern continues, 3 to the 0 power, we would do 3 divided by 3, and that comes out to be 1, which is what we saw in the last pattern, that anything to the 0 power is always going to be 1. And now we get into our negative exponents, and the pattern just continues. So if we have 1 divided by 3, that means 3 to the negative 1 power is 1/3, or we could also think about that as 1 over 3 to the 1st power. And then we can divide by 3 again, And if we have 1/3 divided by 3, that would be 1/9. Or the other way of thinking about that is 1/3 squared. And if we go down one more time and look at 3 to the negative third power, that would be 1/27, or 1/3 to the third power. So hopefully here you're seeing the same pattern that we saw with 2 as the base. Now we're just looking at 3 as the base, but again, when we have something raised to a 0 power, that's always 1, and when something's raised to a negative power, we can make that negative power positive by moving it to the denominator. All right, so now we're ready to jump into our notes. So you can pick up your pencils again or your styluses, and we'll start looking at some examples. All right, so this box at the top here, you see the rules that we just talked about and the patterns that we looked at. So a to the 0 power, anything to the 0 power is always 1. And any non-zero number, they're using a here, and an integer n, if you have a base raised to a negative exponent, that is equivalent to 1 over the base to the positive exponent. And again, that's because of the pattern that we just looked at, where when we are looking at powers, we move down and up, each exponent decreases, we divide by whatever the base is. All right, so just like our lesson previously, it's important that each problem that we look at, we start with the question of what is the base, because that's important to know what the base is. So in example A, 4 is the base. My directions here tell me to write the expression using only positive exponents. So I need to get rid of that negative exponent. So in this case, number 1, this would be equivalent to 1/4 to the third power. And I could calculate what 4 to the third power is, or I can stop there because I now am using a positive exponent, which is what it asked me to do. All right, in example B, we have an m and we have an n. So let's tackle the n first. N to the 0 power is 1, because anything to the 0 power is always 1, again, because of the pattern that we looked at previously. And so now we just have 1 times m to the negative 5th power. So m is the base, so that's what gets moved down. So this would be 1 over m to the 5th power. Now the last one gets a little trickier because we have 13xy to the negative 8th power. So here's where it's really important to ask, what is the base? In problem C, the base is y. So y is the only thing that gets moved down, and the 13x stays in the numerator. So this would be 13x over y to the 8th power. Again, the base here with the negative exponent is y, so that's the only thing that moves down to the denominator. And 13 and x do not have a negative exponent, so they stay in the numerator. All right, let's try some more examples. Number 1, we have 33,333 to the 0 power, which looks big and complicated, but is actually very easy because anything to the 0 power is 1. Number 2, we have 7 to the negative 3 power. We're supposed to write this using only positive exponents, so we need to ask ourselves, what is the base? In this problem, 7 is the base, so this would be 1 over 7 to the 3rd power. On number 3, we have 2z to the negative 2 power. So z is the base, so this would be 2 over z squared. Again, 2 is not the base, so the 2 stays up top, and only the base with the negative exponent moves down to the denominator. Okay, number 4 is another good example of this. So the base with the negative exponent is x, so that's what's going to move to the denominator. The 3 and the y stay in the numerator because they don't have a negative exponent. So this would be 3y over x to the 4th power. All right, now what we're going to do is we are going to combine this with the rules that we learned in our last lesson. All right, so in number 5, just like before, we want to start with the question, what is our base? So in number 5, the base is 6. Remember, the base stays the same. We're multiplying, which means we're going to add the exponent. So this would be 6 to the 12 plus negative 4. Well, 12 plus negative 4 is 8. So in this problem, I'm done because it wants me to write the answer using only positive exponents, and I have a positive exponent. All right, number 6, the base is n. In that denominator, I'm going to add a number 1 there because n is the same as n to the first power. So as I deal with the n here, I have negative 4 minus 1. Because when I'm dividing powers, I subtract the exponents. So this would be 7n, and you can keep change up here if you want. This would be 7n to the negative 5 power. So now I need to get rid of that negative exponent, and n is the base, so the 7 stays on top, and the n to the 5th power moves to the denominator. Let's try the next one. The base is 3, so we have 3 to the negative 10 plus negative 7. I'm adding those exponents since it's multiplication. So this would be 3 to the negative 17th power. And so 3 is the base, so it moves down, and this would be 1 over 3 to the 17th power. Again, you have to write your final answer using only positive exponents. All right, let's take a look at 8. The first question is, what is the base? The base is d, so I have 10d to the negative 4 minus 2. I'm subtracting those exponents since I'm dividing. And since it's subtraction, I'm going to keep change or add the opposite. So I get 10d to the negative 6th power. So I've got to get rid of that negative exponent. The base is d, so the 10 stays on top, and the d to the 6th power moves to the denominator. And again, when it moves to the denominator, it becomes positive. All right, now I want you to try with your partner number 9, 10, 11, and 12. So we'll hit pause on the video, and as soon as you're ready to check the answers to these 4 problems, you can press play. All right, let's go over the answers. So on number 9, the base is m. I'm multiplying those powers, so I add the exponents and get m to the negative 4th power, which is equivalent to 1 over m to the 4th power. On number 10, the base is 8. I am dividing those powers, so I subtract the exponent. So it's 2 minus negative 8, which is the same as 2 plus 8. So that would be 8 to the 10th power, and that's already positive, so I stop right there. Now, number 11 is a little bit trickier. So x is the base. So as I look at just the base, this would be x to the 4 minus 7 power, which is 4 plus negative 7. So this is x to the negative 3rd power. But I also need to deal with the 10 and the 20, which can be simplified. I can divide both of those by 10. So I end up with 1 over 2, and because this is a negative exponent, this would go to the denominator. So the correct answer here is 1 over 2x to the 3rd power. And you know, one other thing to note here real quick is just kind of like yesterday where we talked about how we could extend those. If we look at just the x to the 4th would be a repeated multiplication of x times x times x times x. And x to the 7th would obviously be 7x's. And so as we cancel out those 4, what you notice is the 3 x's are left on the bottom, and so that's why the x to the 3rd power is on the bottom. So again, you can see this relationship that when we have x raised to a negative power, that goes to the denominator, and we can see that proven through the repeated multiplication as well. All right, let's move on and look at number 12. So on number 12, the base is y. So again, 6 and 4 would be the coefficients. That's like what we talked about in the last lesson. So we can multiply those since they're not the base. And then this would be y to the 9 plus negative 4. So that would be 24y to the 5th power, and that's a positive exponent. So I can stop right there. All right, now that's the end of your notes, but there are just a couple other problems that I want to look at real quick because they are going to show up on your homework. All right, so there will be some problems on your homework that will have these directions that say write the following without the fraction bar. And so essentially they're asking you to do the opposite. Whereas before we had an answer and we had to write it with only positive exponents, and so that required us moving some things to the denominator. This wants you to sort of think about it in the reverse way. So how could you write this without the fraction bar, but it would be okay here to have negative exponents. So for example, number 1, where you have 1 over 27, well, we could also write that as 1 over 3 to the 3rd power, because 27 is the same as 3 times 3 times 3. And so if we want to get rid of the fraction bar, in other words, we don't want to have this as a fraction, we could write that as 3 to the negative 3rd power. It's okay here to have a negative exponent because it doesn't tell you that it has to be positive. Then again, if you look at number 2, we have here a over b to the 3rd power. So if you want to get rid of that fraction bar, you could write this as a times b to the negative 3 power. Let me give you one more example. So if we had x y squared over z to the 4th power, and we want to get rid of that fraction bar, we can write this as xy squared, and we can bring that z up, but it would then have a negative exponent. So it would be xy squared z to the negative 4th power. So again, you're just kind of doing this in the reverse way, whereas before they were giving you this problem and asking you to write it with positive exponents only, and so then you would write it that way, or they would give you this and you would write it as that, or they would give you 3 to the negative 3rd power and you would write it that way. Now, these types of problems just ask you to do the reverse, to get rid of the fraction, but it would be okay to have negative exponents. All right, so that wraps up this lesson. Again, I know this is probably a new concept for many of you to have negative exponents, but just remember that the most important question to ask before each problem is what is the base? Because only the base that has a negative exponent will get moved to the denominator. All right, have a great day.